What are the newest XSS attack vectors? Imagine hackers finding new ways to sneak malicious scripts into websites you trust. That's what the latest XSS attack vectors are all about. Cross-site scripting attacks happen when bad actors inject harmful code into web pages, and recent methods have become more sneaky and complex. One of the newest ways involves stored XSS in modern web platforms and application programming interfaces. Hackers target complex systems like social media, project management tools, or code repositories. They inject malicious scripts into data fields such as comments, descriptions, or configuration settings. For example, in some recent vulnerabilities, like the one found in GitLab, attackers embedded scripts into issue comments or pipeline configurations. When users with permissions view this data, the scripts run in their browsers, possibly stealing cookies or executing actions without permission. This vector exploits weak input sanitization and output, encoding on server-side logic that dynamically generates web content. Reflected XSS has also become more sophisticated thanks to social engineering tricks. Attackers craft malicious URL with embedded scripts that are reflected back by the server in responses. They disguise these URL using URL shorteners or embed them in emails and social media posts. When unsuspecting users click these links, the malicious code executes in their browsers. This can lead to theft of session cookies or even hijacking user accounts. The problem here is that backend systems sometimes fail to properly validate or encode user input before reflecting it in responses, making it easier for attackers to succeed. Single-page applications are another hotspot for new XSS vectors. These applications relying heavily on application programming interfaces to load content dynamically. If the backend APIs send user-supplied data without proper sanitization, and the front-end renders this data directly into the document object model, attackers can inject scripts that run immediately. This means developers need to be extra cautious with input validation and output encoding, especially when APIs serve content that is directly inserted into JavaScript or HTML. Hybrid attack scenarios are emerging too, combining server-side request forgery with cross-site scripting. Attackers exploit server vulnerabilities that allow them to make the backend request malicious payloads or internal resources. These payloads may contain XSS vectors that get reflected or stored in the application. When users access the affected pages, scripts execute in their browsers, making this a chained attack. It highlights the importance of securing both server request handling and input processing. Finally, complex input fields like JSON, Excel, or template engines are also being exploited. Attackers send structured data that the server processes improperly. If this data is embedded into HTML, JavaScript, or CSS without correct escaping, it can lead to XSS. Developers need to understand the context where data is used and apply proper escaping strategies for each. To defend against these new attack vectors, it's essential to validate and sanitize all user inputs using allow-list methods. Output must be encoded based on where it appears, whether in HTML, JavaScript, or URL parameters. Using security libraries that handle escaping automatically can help. Regularly updating software and patches, especially for known vulnerabilities like the one in GitLab, is also key. Monitoring API responses and limiting what data is returned can prevent unsafe content from reaching users. Combining XSS prevention with defenses against server-side request forgery and other injection attacks creates a stronger shield. By following these backend security practices, developers can stay ahead of evolving XSS threats and keep websites and applications safer for everyone.